So we would like to find an equation for the tangent plane to the surface x squared plus y cubed plus z to the fourth is equal to 16 at the point 1, -1, -2. So the idea that we need to use here is that if we have a surface which is given as the level surface of a function of 3 variables, sorry, here I'm using the level value 0, but any level value can be used, but it's easier to use 0. Also, please notice that the function f is not explicitly given to us, so we will need to define it. But once we do so, and we have a point on that surface, so let's say ABC, which means that it satisfies the equation, then the gradient of f at the point ABC is perpendicular to the surface f of x, y, z at the point ABC. So in other words, the picture that you have is something like that. So let's say that this is your surface. Then the gradient at the point ABC looks something like this. Or maybe it points to the other direction. So again, we're assuming that this is the surface f of x, y, z equals 0, which means that you have everything that you need, meaning if you want to find the tangent plane, you have the point ABC through which the tangent plane should go, and you have also the gradient, which is the normal vector that you're looking for. So you're going to use the standard equation in the case that this is the data that is known. Okay, so let's see how this is done after having given all these explanations. What we will do should be pretty straightforward. So we begin by defining a function that we can use, because we, in the statement, which is in green, we don't have a function. So we define f of x, y, z to be equal to x squared plus y cubed plus z to the 14 minus 16. Then the given surface is all the xyz's such that f of xyz is equal to 0. And this is what I meant before when I said that we can take the level value here to be 0, because all you need to do is carry all the elements of your equation on the left-hand side, set it equal to 0, and then define the function accordingly. Now it's very simple to find the gradient. So f sub x is going to be 2x, f sub y is 3y squared, and f sub z is going to be 4z cubed. Let's do the substitution carefully. So the gradient at 1, -1, -2, which is the point under equation, is going to be 2, 3, and -32. Okay, and now that we have the gradient and we have the point, we can get the equation together. So the equation, or rather I should say an equation, there is nothing unique about that equation. So an equation for the tangent plane will be given by two times x minus 1 plus 3 times y plus 1 minus 32 times z plus 2 is equal to 0. Again, all the information that we need is right here. So this is our point, and this is the normal vector. That's all we need. We put this information together, and we get our equation for the plane, which will have the format that we've seen in the general case when we know the normal vector and or a normal vector and the point that belongs to the plane. And this is our tangent plane. This is an equation for our tangent plane. And that's all. Thanks for watching.